Hello, welcome to A-Level Physics and Mathematics. In this session, we are going to discuss about torque. Before that, let me ask you a very simple question. Did you subscribe to this channel? If not, could you please just make it right now? You can subscribe, like, and then share with your friend. That will help me a lot. So, in physics, torque is, as you know, that it's a turning effect of a force, right? Or we call it a rotational effect of force is called a torque. That is what we call it, a torque. So let's say, let's basically we have this is a symbol of torque, which is tau. It's a Greek letter tau. Then we have basically an hat, which is it indicated that is a vector quantity, so which is equal to force multiplied by a lever of arm, right? Lever of arm. So that is how you need to calculate the torque. So what I'm trying to show you to you guys is basically, as you know, I believe everyone is familiar with force. So it's just this pull or push of an object, right? So, but the challenging part is kind of a lever arm. So that is what I just wanted to share with you guys. So like I said, torque is a rotational or a turning effect of force is called torque, right? Or you can calculate it, you can multiply it, you can symbolize it. The symbol of torque is tau, which is a Greek letter, like I said, which is equal to force time or that lever. We will see that within a couple of minutes. So that is lever arm. So to find out this lever arm, so what I was trying to find, lever arm, what you need to do is we have a couple of procedure to find out the lever arm. One is what you need to do is find the distance. Okay, so find the shortest distance, or what you need to do is extend. Okay, extend the line of force F. Okay, extend the. I will show you that what does it mean. I will show you this within a few minutes. So next, what you need to do is basically you need to find the shortest distance. Okay, distance no, it's supposed to be distance from the line. Okay, from the line F or a force to the find the distance, the shortest distance from the line F to the axis of rotation. Okay, to the axis of rotation. Okay, rotation. Okay, so that is what that is how you can that's how you can calculate the lever arms. So what does it mean? That we can see that let's say you have a door. Okay, let's say I will show you what this. So let's say this is a door. Okay, let's say you have a door, right? This is kind of house, and then let's say this is a door. Okay, and then there is a turning point, or this is a rotational point or axis of rotation, right? So let's say this is range, right? We call it basically range, right? So this is range. Sometimes we can use 2 or 3. It depends upon the house that you did. So build. So let's say this is a range. So we can take, let's say this, from this we can take, you can take basically any of them, but what I'm trying to do is I will take this range to find out the lever arm. So what you can do is you can represent this look like this, okay? So like I said, this is axis of rotation, okay? This is an axis of rotation, and then we call it this, basically you can represent this R or the position, okay? This is a position you can use to represent, you can use R to represent the position from axis of rotation to the knob or a handle. There is basically a handle somewhere around here, right? And then, like I said, this is an axis of rotation. So let's say if you did apply a force somewhere around here, so let's say this is a F, okay? This is F. So this is an F or a force that you are trying to open or close a door, because like I said, there is a kind of knob or range somewhere around. I mean, the handle is not range. Range is, or axis of rotation is over here, okay? So from here, what you need to do is you just need to follow these few steps. So what the first guy is saying, that extend the line of force, right? Let's write on the bar line over here. So that is it, and then you can extend from this side as well. Now what you need to do is the next step is about find the shortest distance from the line of force to the axis of rotation, right? So our axis, our rotational, I mean axis of rotation is over here, so we can find the shortest distance. Let's say this is the distance from the axis of rotation to the line or the force, okay? I mean the line of force. So basically this line is a lever arm, which is must be which is perpendicular to the force, okay? To the force. So like I said, this is an axis of rotation, axis of rotation, okay? Rotation. And then this guy is, like I said, this one is an arm or lever arm. We call it a lever arm, okay? So that's it. And then let's say if you extend this line, and then you will get an angle psi, or let's say an angle psi, or let's say an angle theta, okay? So now what I'm going to do is, as you can see, this angle and this angle is kind of vertical opposite angle, right? So based on the rule or the principle of the vertical opposite angle, they are the same, right? They are exactly the same. So this angle is equal to with this angle. I know this is an rectangle, I mean the right angle triangle. So now using a trigonometric relationship, where you can do this opposite side, this is an adjacent, this is opposite, and then this guy is an hypotenuse, right? So the lever arm is equal to, basically it's not a lever arm, so the sine theta, right? Sine theta is equal to lever arm upon lever arm over what? Supposed to be arm, right? So lever arm over position, okay? Lever arm upon or over position. So meaning that from this relationship we can find out a lever arm is equal to a position multiplied or the displacement, or we call it basically distance or displacement, it doesn't matter. So sine theta, right, which is an angle between the position as well as the force exerted on the door, okay? So that is it. And then from here, what you can do is that, as you can see, this is a lever arm, meaning that the torque of an object is equal to rotational motion or rotational. Basically, the torque of an object, we call it the torque of an object, or torque is equal to a force time or multiplied with the position sine theta. Okay, that is how you can calculate the torque. Okay, sometimes basically you can use torque is equal to for torque is equal to the perpendicular force time r, or cross product. You can use a dot product or cross product, so you can use this formula as well. And then I just wanted to let you know something about this torque. Basically, what I want to trying to say is what I was trying to say is that the SI unit of torque is, as you know, that the SI unit of force is a meter, right? SI unit of position is meter. So meaning that the SI unit of torque is the SI unit of torque, right? Torque is what? Newton meter, which is an SI unit or the standard unit of torque. I just want to ask you guys one question. So let me could you please share your your idea about, let's say, if you apply a force over here, okay, in a range. If you apply a force in the range, what is going to happen? Or what I just want to what is the torque? Okay, if you apply a force, this force, we did apply a force in the under, right? We did while we were trying to open or close the door, right? So that is why we did apply a force over here. Let's say if you apply somewhere around here, what is the torque? Could you please your thought in the comment section? So yeah, maybe I will reply, and I will reply for you in the comment section as well, or we'll proceed in the next section. So that is what I want to let you know. So I think that is all for today. If you have any concern, or if you have any question, you can feel free to put your question or your thought in the comment section. I'm happy to reply to you guys. Yeah, that's all for today, and then see you in the next section.